Thank you, Paulina, for speaking to me. I'm today speaking to Dr. Paulina Lopez, who's a glaciologist, a cartographer, water expert, currently working with UNESCO in Paris. She has a lot of experience. She's actually the only woman glaciologist I've ever met. So thank you very much, Paulina, for agreeing to speak to me about this project, Samtal Jameen, Samtal Jameer, think of the multi-species world. And as you know, in the project, I had suggested first that if you want to react to any of my photographs, and then if you'd like to, otherwise we can just start talking about your experiences as a glaciologist and other experiences.
So thank you very much, Ravi. I'm very happy to be part of this project. I'm really grateful, in fact, because I really feel like these kind of conversations are not only interesting. I think they are really necessary to have it, because it's a conversation in between different disciplines and different perspectives and point of view. So I'm very, very happy to be here and to be able to talk about my experience and to react to your pictures too. I would like to start talking to you about my work. So as you said, I'm a glaciologist, I'm a cartographer, I'm a weather expert, and I explore also a little bit social sciences in India for a while. But today, what I will bring about is the idea of glaciers in order to discuss how we see glaciers and how the understanding of nature and the perspective we have, it frames so much the manner we see the objects in nature. No? I would like to talk about my experience of going to the field a lot and how I saw those landscapes and how I understood glaciers before and how this idea has changed so much with time. And it's changed because of interactions with people. It's changed because of curiosity. It changed because of people living there, because of many reasons. So I don't know if you want me to start discussing about your pictures, or do you want me to? Because I prepared some material for my fieldwork. So I don't know. You tell me what you want.
So we can start with my pictures, then we can go to your
okay, good
fieldwork.
Yeah. So in fact, I chose 3 pictures. Of course, I found them all very interesting, and I have a view of all of them. But there are 3 in particular that really I would like to discuss about. And this is the first one is growth. For me, it represents really what happened today, what we are seeing in the frame of the Anthropocene, and how we have interact with nature. Okay, so I guess on the back is a kind of bridge or a kind of what is this infrastructure which is on the back?
It's a bridge over the river.
It's a bridge over the river. So this is what, for me, it represents how we have defined nature as human beings. We have taken nature as a resource solely. We have intervened. We have taken and not giving back anything. Even this division in between human beings and nature, it says everything. I found this picture very interesting because so there is a tree in the middle of nowhere. And I really think that nature is its process of regenerating despite everything. I have seen things, growing, especially in India. In India, it's like everything grows by everywhere. And so it's like nature is there, and we have not understood anything. We have not understood that we are part of it, that it's a continuum of everything, that it's not a matter of divisions. So this is the first picture. And the second one is labor, of course. For me, it really represents this idea, this idea of nature as a resource only, not as something that exists, that we are part of it. This picture is very strong, I think, because it also represents the political and economical structures that are behind nature today. I mean, or how we relate to it. It's a very hard picture to have this small child carrying these bricks. Of course, it's a very hard reality, But also at the same time, we are all part of it, I'm doing that to this girl. You are doing that to this girl, because we are all part of. We are all enjoying of this of this economic system, of this political system in which we're part of all of it. So we used to talk about the capitalist system, but we are the capitalist system as well, because we are not in the point to abandon certain things, comfort in many ways, life standing, all of these things. We are not willing to leave these things aside. And yet we talk about capital. I talk about the capitalist system as something like a third person doing something. We are part of it. And this, I think, requires I think we reach a point in which we have to think really from other dimensions, deeper dimensions of what we are doing and how we will do in the future. So for me, this is a very powerful picture. I really like it. And the other one is this one. It's classification. So of course I will react to this picture because my background is a scientist. I'm from natural sciences. And it talks a lot to me about the manner how science has been developed. So I have an idea of classification, which we can blame a lot science today, to say, okay, science divided everything. Since at least the Enlightenment, there was a big revolution of how we understood things and this faith in science, and it became also very political as well. And we blame it, classification. But what I think is that the problem is not that we classify. I think classification is necessary. You define as an artist, I define as a natural scientist. This is a classification. We can say this is, this is a bird and this is something else. Classification, I think, is a part of our nature, is part of our thoughts, but the problem is what we do with that classification. I think the problem with science and how we have understood it and the impacts in nature through technology in particular, through this permanent idea of finding solutions through technology, especially if we talk about water as a resource. We continuously construct dams and many things in order to find solutions to water scarcity, for example, or to regulate the water availability, etc. So this is a problem, that there is imbalanced way of applying science and technology. And this science comes from this classification in many ways. So I don't think that we can take it out. I don't think it's bad. But what we have done with this is another question, is something different. And this should be questioned and criticized. So these are the three pictures I would like to comment.
Thank you. Coming back to your own work as a glaciologist, where you spent long years of your life living on glaciers, examining glaciers, and I remember you describing them as living glaciers. Yeah. And what does that mean? What has been your experience of living in such barren, desolate landscapes? And how do you see these landscapes?
So first of all, I would like to precise that I was working particularly in Patagonia region. And I'm saying that because that region and the glaciers that you can find there are really, they have very particular characteristics. They are very big, they are really enormous. And they are what we call Calving Glaciers. So Calving Glacier is a glacier in which the front lands on water, and the last part of the front of the glacier is floating. Okay, and from those glaciers, icebergs are formed and so on. So all of those glaciers are Calving Glaciers. So they are it's a very impressive landscape. Also, personally, I knew Chile, which is not my native country. I knew it. I traveled to south of Chile, to the north a little bit. But the first time I went to Patagonia, this nature was so impressive and so that I didn't have any filter, a rational filter about what I was seeing. It came really something very emotional. It's the first time a tear came to my face because it was so impressive. It came directly to my soul. It was something very special. And I'm not an emotional person at that point, but it happened to me, I just say. And I went there as a scientist. No? So So when I arrived there, I was I had a very particular objective, which was an investigation to do. So the purpose was to study the retreat of those glaciers. So the first time and the first years I went there, it was with that purpose. So then I used to install stations, hydrological stations close to the front of the glacier. And then I started measuring the mass balance of the glacier itself. So the mass balance of the glacier is the relation we establish in between the two main parts of the glacier, which is the accumulation and the ablation of the glacier. So I don't know, should I explain? I mean, what is a glacier and what just...
Yes, please explain.
Okay, yeah. So a glacier, it's in fact, is very simple because a glacier will be formed in a place in where snow starts accumulating. So snow starts accumulating and it is in a slope. There is a slope. So then snow starts accumulating and start moving downwards. And because of compression, because of the accumulation, then snow becomes ice. So there are two clear parts of the glacier, one part in which snow accumulates and the other part in which ice melts. And from the scientific perspective, we propose an equation which allows to understand the state of the glacier, which is the mass balance. And the mass balance is the relationship in between the accumulation and the ablation of the glacier. When this mass balance is negative, means that the glacier is losing is melting more than it accumulates. And when it's positive, means that it's gaining more snow than it melts. And when it's zero, means that both parts are equal. So my purpose as a scientist was to calculate that mass balance, but also to see the impacts on the water of the river originated from that glacier. I would like to show images now.
Yes, please show.
Because then you have an idea where I'm talking about. No?
Yes, we love it.
So I will show you some maps. So the area I'm talking about. So this is South America. Okay.
Yes.
So this is Argentina. This is Chile. There are three big ice fields in this region. Which is the Northern Patagonia ice field, the Southern Patagonia ice field, and Darwin Cordillera. They are the main ice mass besides Antarctica and Greenland, of course, and the biggest of South America. Okay, so I used to study this ice field, the Northern Patagonia ice field in particular. I studied three of them, but in particular this one. Okay, I would like to show you. This is a map I did myself. So this is Northern Patagonia ice field. So you see, this is an ice field. In fact, it's a very simple. It's a big, enormous mass of ice composed of several glaciers around. So it's a plateau in the middle. This is a plateau, and so a plateau is quite a sort of flat area, and then many glaciers are around, going downstreams. And you see that these big glaciers. This is a Pacific Ocean here. And all of them are calving glaciers. So some of them, like this one, San Rafael Glacier, it's a tidewater calving glacier, means that it calves in salty water because it's already mixed with the water coming from the ocean. So I used to study this glacier, Neff Glacier, and Stephen Glacier. Okay. So in the frame of those investigations and in that region, I started going to glaciers. And in my imagination, so a glacier was something very compact, and I knew that, of course, it has a dynamic because it moves and etc., etc. But what I found in the field, it was something completely alive, but completely alive in every sense of the word. It has noise, it has movement. A glacier has life inside. There are real rivers inside the glacier. So this is a picture of a camp in a little bit of high altitude. This is the front of a glacier there in Patagonia. So you can see this is the end of the glacier. It's a very chaotic mix of stones and dust and ice and water. The glacier is calving in that manner. Okay. What we have to understand also is that what we see here, it's 1/9 of the whole theoretically, of the whole thickness of the front, We see only a small part of what is inside the water. You see, this is really interesting because you see they keep the history of what is happening at the surface of our Earth, in fact, because they keep it, they capture in the ice. And then that's why, for example, the samples that we will take in order to understand the climate of hundreds of years ago is because ice will keep it forever. You can see the layers so clearly. So this is a current life and a past life also that you can see it. So this is another glacier in this ice field I was talking about. This is Leonis Glacier, the name. So this is the same glacier in the glacial lake coming, and then the river. And you can see also, you see this dark part of the glacier. They are covered part of the front of the glacier. Okay. And this is also, of course, very dynamic because when the ice is covered by a little bit of sediment like this, or debris, in fact, it will impact the process of melting of the glacier because this sediment will capture a lot of solar energy and they will accelerate the melting process. So you can see how stones and everything, it's mixed up because the glacier is a movement. So it takes everything which is around. And so this is just a cavity, which is very normal to find it. But this is a small one. I will show you some others very big. And this entering to another world inside. You see, this is enormous. This is a crevasse. So, and the glacier is full of crevasses now. You know, we are walking here. You have seen this picture.
Is it safe?
It's a very unsafe place to be. You take a lot of risk. I already lost, many colleagues and friends, glaciologists. It's very risky. You can imagine where you are walking. Mm-hmm. You don't know if the next step, which is a crevasse covered by small layer of ice, and your weight.
Who's taken this picture from how far?
It's a colleague. She was installing a GPS station in the hill while we were installing some stakes and instruments.
It's amazing photograph.
Yeah, very amazing. Yeah, because you can when you are in the field, you don't see this dimension of the whole picture where you are. You don't see it. You're just seeing the step after the other step, but you don't see where you really are. So,
wow.
Yeah, this is you see this.
Amazing.
Yeah, it's true. It's you can see the crevasses and the dust and on the surface. It's still the same thing. So you can see on the back of the picture these lateral moraines. So they are the testimonies of where the glacier was before. You can see the difference in between, different colors, very dark and then lighter in the sediments on the back. And you can see how much the glacier has lost mass. The ablation is so strong that because the glacier was on the top after. Do you see it? Yeah. And so this is a sign of melting also because you see the small lake. A lake started forming here. It's because the melting has been accelerated. So this is okay. I will show you this instrument later in more details. We use this to install stakes in order to measure ablation.
Are they melting more because of climate change? No.
Yes, of course. Yeah, they are melting. They are melting more because of climate change. In Patagonia, this is evident. And so in Patagonia, it's in fact complicated in general. With Calving Glaciers, it's complicated because, of course, the glaciers will react to changes in the air temperature, in modifications of precipitation, because they are directly related to those variables. But for calving glaciers, for example, the temperature of the water in which they are calving, it's another factor of melting. If there is salt in the water, then it will accelerate the melting process too. So they are more complicated to understand and to measure. And also they have a nonlinear movement of the front, means that when they start losing mass, they become thinner, and then they become weaker. So they will break they will have a very big breakdown. So then they will lose a big part of the front, and then they will remain stable for a while, and then they will lose again. They can lose 1 kilometer in what the front can break, and then 1 kilometer of the glacier is gone. They work like that. This is the dynamic of calving glaciers. Instead of non-calving glaciers, so glaciers that just land on the ground, and then on the ground, those glaciers will have a linear retreat. It's year after year, they are losing a little bit of the front, and then some of them, they disappear. Like, for example, in Bolivia, there is one glacier called Chacaltaya. It's almost nothing now. That's why calving glaciers are complicated. And of course, fieldwork is so tough, because of the size, because they are very remote.
You get to know the glacier by its measurements, by its movements, by observation.
Yes, there are many types of observations. So it depends what is the observation that you want to do, what you want to understand from the glacier, okay? Because you can try to understand the dynamic of the glacier, for example. For that, you need to understand the movement. You need to know the bedrock of the glacier. And for that, of course, it's so difficult to have an idea, and you can't go inside the glacier, of course. So then we can know. I mean, as human beings, we can know, and through technology, using radars and these kind of instruments, we can have some models of it, so some interpretations. But they are limited, even though we have advanced quite a lot. Of course, I mean, we know more than we knew before, that's for sure, but we don't have a full picture of what is going down of the glacier. For the dynamic of the glacier, this is very important. For the mass balance, you go to the field and you do what I will show you, or we use airborne methods like altimetry, laser altimetry, or radar of this kind of, but it's very limited and very complicated because you can't use this technology in any type of glacier, and it's very expensive. So this is another glacier in the same ice field, this is Exploradores Glacier. Very difficult because it has a part which we call death ice, which is it has a disconnection from the glacier, but still ice remains. This is my dear nephew glacier. I studied this glacier many years. And you can see the Pro Glacier Lake here, and then the river started here. So my research was focused on the study of the glacier, but also of the river. So I will show you how we installed an hydrological station there. I wanted to see the contribution. I wanted to quantify the contribution of the glacier to the river, and to project in the future under climate change scenarios how much water will be, what will be the availability of water if temperature increases or changing some climatic variables. So this is the glacier. This is my very first fieldwork experience. It was the first time I went there. Mm-hmm. And at that time, we didn't go to the glacier. The fieldwork wasn't planned to go to the glacier. I was just looking from outside, and I promised to myself to go to the glacier itself one day. Is what I did after. So this is my mentor and friend, Gino Casasa, measuring in its high altitude in Patagonia. He's using a radar. That's why I'm showing this picture. So this is a radar in which you can have an idea of the thickness of the place where you are. I wanted to show this picture because these are the samples of after an operation, very big and risky operation they did in order to collect one sample of ice and snow in a hill. I mean, in a mountain, very dangerous, a San Valentin mountain in Patagonia. It's the highest one in Patagonia, which is not so high, but the conditions are difficult. That is very, very risky and difficult to get there. But they succeed to have this. So this is just another fieldwork going in by helicopter because there was main transport main way to go to get these places. Otherwise, it requires days and days and days of riding horses or walking. So this is a stake. This is just to calculate the melting. Okay. Mm-hmm. So what we do is we drill the ice first, and then this is a stake. Okay. Mm-hmm. I just install stakes of 50 meters. So we have to drill first the ice of 50 meters, and then we inserted the stake. And then this is we have to do that in the beginning of the melting season. And then you have to go often to the field in order to see how much, you measure how much of the stake is out of the ice.
Mm-hmm.
So, and this, it gives you the idea of the melting. So the thing is...
How thick are these glaciers?
Oh, we can have an idea, very certain idea, but with radar we can say that it's more than 100 meters of several hundred meters.
Several hundred meters.
Several hundred meters. Yes.
Wow.
Yeah. So imagine that in that glacier, which is not very big compared to some other glaciers in the same region, I installed those stakes of 50 meters. So in between November and February, the stakes were the whole stake was outside. Means 15 meters, just 15 meters, just like that.
Oh.
And this is just the annual dynamic of the glacier. Mm-hmm. Can you imagine?
Wow.
So, and also, when we install these stakes, one big difficulty is to find them after in the glacier, because the glacier is in movement. So we install in one place, but then it will be very far away. Mm-hmm. So
like a river.
It goes very quickly. It's like a river, a real river in movement. Really. And this is a landscape just nearby the glacier. This was the camp base we have. This is a very old house of, typical in the Patagonian valleys. This is just water coming from this house. So this is a little bit in altitude in the accumulation area of the glacier. Mm-hmm. So we were measuring the snow density here, which is a parameter very important in order to calculate the volume of water contained in the snow. So this is another area. It's in a volcano in Chile, installing a meteorological station in order to measure air temperature and precipitation and humidity, these kind of basic parameters.
Yeah.
This is a video, that's why it's not opening. So here we are measuring the water flow. And this is Pedro, my friend who passed away in the fieldwork. And this is the landscape around. This is Patagonia. In Patagonia, water is coming by everywhere with such violence and such, like a kind of, it is like this by everywhere. I selected pictures, but some of them, I had so many, Ravi, you can't imagine how much I spent selecting and trying to.
No, thank you. This is fascinating. To know how a scientist knows a glacier.
Yeah, that's why I wanted to show you everything. I didn't want to show you only the glacier. I wanted to show you what is behind of the scene of all of these things.
Yeah.
I have some videos I will show you after. So this is a Stephen Glacier. So this is the big glacier of this map I show you. Very difficult, completely difficult. So here it was the same manner of proceed, means that the program was to install this hydrological station in the proximity of the glacier front. And the plan was to measure the glacier itself. But unfortunately, here we had a big accident, so I didn't continue this research. But we were be able to install this station. And now it's running again, because the ministry took charge of it, took it over. So this is how we proceed in the field. Ravi, do you see this small instrument here?
Yeah, I do. Yeah.
So this is a hoike. We call it hoike. It is so simple. In fact, we fill it with water, and then we light it with fire. It's like a whole hot water thing you have in your house. My old house in Chile had this system. You light it, and then you hold the water, and then through this tube, vapor is coming. Water vapor.
Yeah.
Okay, steam. So, and we melt the ice with that steam. So we melt it to 50 meters, and then after that, you see the stake is here. It's segmented in 1.5 meters, and then we put it on the ice after. Insert it in the ice.
Mm-hmm.
Okay.
And what do you measure by that?
The ablation.
Uh-huh.
This is the stakes I was talking about.
Right.
In the beginning of the melting season, you insert it in the ice, and then as ice starts melting, melting and melting and melting. These stakes are at the surface.
They're exposed more and more.
They're exposed more and more. And then you have to go to the field several times to see where they are and to measure them.
Mm.
So this is it, the traditional and the classic glaciological method. Very necessary. I mean, it's nothing replaces it as yet. There is no technology replacing this glaciological method. So this is the way of going there. You see horses. If it's not helicopter, it's horses. The horse is carrying the instruments and stakes and many things, no batteries and generators sometimes, and a lot. It depends of the extent of the glacier, of the field work, of course. And this is the ambience of evening ambience, no? Or, cooking with fire. Some people living there who are helping with the field work. These are the guides, very important. This is I don't know if you see the shoes after a whole day of they used to be completely wet, and again technology. There is not technology able to ensure that you will have a dry shoe all the time in this kind of landscape. It doesn't exist. It's the same for clothes. They will resist for a while, but after one day under the rain, Patagonian rain, it's nothing resists.
Everything is wet.
Yeah. So these are some tools and instruments. So this is this is the way of doing it. This is the stakes. This is the hoikey again. Again, the same thing. So you see these things. These are real rivers going inside.
Oh.
Look, this big stone carried by the glacier.
It's a stone.
Yeah, this stone. You see, enormous.
It's like industrially chipped square.
Yeah, absolutely. It's like a perfect square. You can do a piece of art of it. It could be easily.
Yeah.
No, you don't think so?
Yeah.
Yeah. So this is another field work. He's a filmmaker. So he did a fantastic documentary film because there was in that region before there was a plan to build an hydropower station, very big one, enormous. So there was a big movement in order to try to prevent that installation. And he decided to do a documentary of the area. Very nice. We appear in that documentary because we were doing this field work with him. He was filming what we were doing, and he interviewed us a little bit. So these are prominent glaciologists. So this is the same field work, and this is Gino, and this
the famous Gino. He's a very famous glaciologist, no? World famous.
Very famous, yes.
Yeah.
Absolutely. Yeah, very famous by everywhere internationally, and of course in Chile, he is very well known. A fantastic man also. Yeah, and he's Hiro Koshima. Hiro Koshima is a prominent scientist also. He's an academic of the Tokyo University. And it was very interesting to do fieldwork with him because he was studying the living organism living in glacier.
Oh, I see.
Yeah, so it was very interesting. I will show you.
So he's some kind of a biologist or a...
He's a biologist.
Ah.
He's a biologist. He has studied Patagonia during years and years. Of course, a very, very good scientist and very passionate. And in this field work we did together, he was he spent so long time looking the eyes. Long time, whole days, looking at the eye. And so his eye became damaged. Because, eye has a very strong...
UV coming out of it.
Yeah, with albedo, it's very strong. I mean, it's really very high. And so his eyes were damaged. So he has to spend 1 or 2 days on the darkness in order to recover because he couldn't see anything anymore.
Oh.
He wasn't using sunglasses to see better. He took it out and then he was
damaged.
Yeah. But then after he recovered, he came back to the glacier. Yeah. So Hiro is looking. This is Colonia Glacier. So this is part of the whole team. with the guides and the scientists and the filmmaker. And there was a journalist also. He published something in a magazine after.
Mm-hmm.
So this is Gino looking at the glacier.
Wow.
Yeah, so this is so many pictures.
So if you go there after some time, it might look different, no? The glacier is shifting all the time.
Of course, you will never find the same thing even in 1 week.
Even in 1 week?
Even in 1 week. So when I measured with my stakes, I measured the velocity of the ice, and if I don't remember badly, it was 6 meters per day.
Wow.
Which is enormous. It's very big.
Mm.
I hope I'm not making a mistake on the. This I have to confirm because I don't remember exactly. So this is, you see, this is a typical meteorological station that we were studying. Can you imagine to bring all of these metallic structures with the drill and with everything that it has to? It's such a big thing. For that fieldwork, we took 120 kilograms of charge.
Mm-hmm.
So this is Hiro taking samples from the water. Oh yeah, this picture I would like to show you. So you see, look.
Wow, me, like a river coming out.
I love this picture because you can see, it's not coming out really with time maybe. You don't know what will happen. But you see what is, like cavities, a glacier is that. And inside is in movement all the time. It's never static, never. So this is another station.
How old will such glaciers be?
How they will be in the future?
Oh no, they have been.
Oh, since so long time.
Ice age.
In this is in the quaternary. They were already in the quaternary. In Patagonia. Yeah. No, they are absolutely old. Very old.
But they also old, but they also renewed all the time.
Well, this is not for granted because if they continue at the rate that they are melting today, they will disappear as the other glaciers have already disappeared in the world. Yeah, so Patagonian glaciers are very big, but if you see Antarctica, if you see Greenland, those ice masses will disappear.
So some of those ice could be that old, which is still there.
Yeah, because they have renewed until now. They have renewed until now because the climatic conditions allow them to be renewed. But if those climatic conditions they change, this will not happen. No, it's connected. It's not unconnected. It's not because the ice is there today that they will remain there despite everything. They will disappear.
So whatever we are doing in the rest of the world changes this landscape constantly.
Absolutely.
The temperature, must be the pollution,
absolutely.
Everything.
Yeah, absolutely. And this is a climate change impact. This is for sure climate change impact. And climate change should be understood as a modification of the whole climatic system, of the global climatic system. Because in this region, in Patagonia, some two glaciers are retreating. At the time I was investigating on that, if you go to the Tierra del Fuego, which is even more on the south, some glaciers were in a steady state, means that they will not retreating, they will,
mass balance is constant.
Exactly. So then how can you understand that in the little bit on the north, they were retreating very fast rates, and more in the south, they were stable. And this is climate change. It's a modification of the climatic system, full modification. And everything is interconnected, everything. We studied a little bit the impact of the modification of the wind, because this region is very exposed to the westerlies, strong winds coming from the from the Pacific Ocean, bring a lot of humidity, a lot of rain, a lot of things. And we tried to understand how the modification on the westerlies can impact the evolution of these glaciers.
Mm-hmm.
What I did, I took all of these pictures, and you can have an idea of what it means to go there and so on. And then I will show you what we did with that.
Yeah.
How we translate it and how we represent it. And the problem it started for me there. I will show you. So these are some pictures of the water inside the glacier.
Oh, wow.
You see?
Mm.
There are real, swimming pools inside.
Mm-hmm.
You can swim. You jump there and then you go meters and meters down. And movement, constant movement. And you can hear the noise and you can see how it is.
Aren't you scared standing there on that corner?
Now I will be. At that time, I wasn't scared. Anything scared me at that time.
Now you will be scared.
Now I will be scared. My perception of risk, of course, it changed because I experienced many things after that. But at that time, I wasn't scared of anything at all.
But you're on the edge of something, edge of a water body.
Yeah. I could have felt 100 times there.
Yeah.
And they stopped me because I wanted to go further. They said, no, go. Yes, true. So look at this.
Wow. Beautiful.
Yeah. Okay, let me find this video. Oh, yeah, it's this one. Okay, I have to find it.
You're standing on the edge of the video.
Yeah, I'm standing on the edge.
Wow.
Yeah.
So scary. Well, there's really deep water.
You see?
It's like a crevice.
I mean, this is more like a crevasse. Mm-hmm. It is a crevasse. It is in fact. It originated as a crevasse, but you see the water already made something different of the crevasse.
Yeah.
Because it started melting and flowing inside and so on. It's a pond.
And where does the water go from here? It's like a pool or it's flowing out?
So normally it goes and they're flowing to the river. It should go to the river normally. Not all of them. There is a case in the glacier La Tête Rousse in the Alps, French Alps, in which those ponds are blocked inside the glacier. Mm-hmm. And there was a big disaster because once, it flowed into the village suddenly.
It burst.
So now, it burst. Yeah, completely.
Like what happened in Uttarakhand also in India.
Exactly. So what they do now, they drain it. They go and drain it, take it out of the water because naturally the glacier tends to accumulate it and then it breaks, no? Because the pressure of the water becomes bigger than the capacity the physical capacity of the glacier to stand the water. And with climate change, it happens that as the glacier becomes thinner and thinner, it becomes weaker and weaker. So that's why these glacial lake outburst floods are increasing.
And when you stand in the glacier, you can hear it.
You can hear that, no? This is the noise of a glacier.
Yeah.
This is here. And I will show you some other pictures of, because once we were measuring the snow, there was a small avalanche in front of us. Mm-hmm. And I will show you here. So this is in the upper part of the glacier, so in the accumulation area where snow is. Mm-hmm. And this was a small avalanche. We were in the other side in the other side, no, in an elevation a little bit. So we were just there and having lunch, or we were sitting there, and suddenly small avalanche. And I don't have any film, unfortunately, of that. But this small avalanche has the noise of, it was like a bomb. Oh, I'm telling you, it was so scary. This was scary. And then I was scared. And it's a very small one, look. This is all snow. Mm.
It shows how insignificant the human being is in this landscape.
It's exactly it's exactly how you feel. It's like a small thing trying to understand a big, enormous thing. It's pretentious to think. I really feel like it's pretentious to think that we will be able to understand unless you surrender to that and you're part of it. Yeah. And you understand yourself as part of it. That's it. I mean, I think it's the only thing we can do.
But you told me once that people who live near these glaciers or on these glaciers, on the glaciers?
No, they don't live on the glacier. Yeah, so this is a picture of one very important explorer of Patagonia. He was a priest. So Alberto D'Agostini. So he explored during many years this region, and he is a Patagon, Indian Patagon living in that region. They were extincted very, very fast.
They no longer are there.
They are not longer there. No. With colonization, they were all extinct completely. And by the way, they were in such difficult conditions. They were whale hunters. So can you imagine at that time? They really had very tough condition of living, and Darwin passed through this area. And when he saw them for the first time, they said he thought these are not human. He compared like animals because they had such a bad looking and everything because of it's such very tough region. This is a typical Patagonia house inside, not in the valley itself. This is like more like and he's a professor studying the area. So he's a sealer. So this is a region of sealers also. And this is the typical people in the valleys. They live in these small houses like that. I should show you something else before to understand. Because in fact, there is a big river that disconnects the civilization, let's say, and what happens in the valley, okay? So after the river, people live like that. So this is the landscape. So, and the landscape is very disconnected, connected and disconnected. This is how you do there, no? You have roads, and then you have to cross a lake of a river, and then you take this ship, and then you go inside with car and horses, and you put everything inside, and then you go to the other side, and then like that. So this is such a windy region, It's this is a house of a couple of Germans that settle in this area, and very close to a glacier. Nobody knows how they manage because they just settle there. So this is another explorer, Grosser. He did many explorations, and he really advanced the knowledge of glaciers. And this picture I wanted to show you because this is water coming from the glacier with a lot of sediments and mixed with water coming from rain. Yeah. So he's living in the valley where we used to do our fieldwork, no?
So they traditionally live in the valley. They are from generations, very old.
This is incredible because, in fact, yes, they live there, and the child that's born there, and they don't. Now maybe it's a little bit more connected. Maybe child they have the chance to go to the school in the village somewhere, but families they just live there and they don't know anything else apart this local life. This is very, very interesting because I used to go there once. I asked them, I showed them a map because I was talking to them about the glacier, which is very well known because it's a very touristic place to go. You go in a ship, and then you have a glass of whiskey with the ice, with the millions of years ice, and then you take the picture and so on. People there, they don't know that glacier. When I talk to them, San Rafael Glacier, they say, what is that? And I said, yeah, just nearby. And then I showed them a map, and they didn't know about where the whole picture of the place where they were living. So they lived there, they developed there. Once we met a man, he was lost in the valley. Really, there was nothing. The house was like this house I show you where we stay after the field work. It's not a whole house, with the 4 walls. It was only like just covered in the lateral, and then he was sleeping there. And we asked him, "Do you come from here?" And he said, "Yeah, but my wife, she didn't come from here." And we asked, "Okay, where did she come from? Because she passed away." And so, "Oh yeah, no. He said she came from the other side of the river, and the river was just there. So she came in from and for him, she was somebody coming from outside, you see, an outsider."
Yeah.
Yeah.
So how do they know the glacier differently than you do? Because you do all these instruments and you have the experience. So how do they describe the glacier? Is it different than the way you do? Do they have different stories about the glacier?
They do have, because first of all, they see it at the daily basis.
Mm-hmm.
So they will be able to, of course, to describe in terms of, in a very pragmatic manner, in terms of evolution of the glacier. They will be able to say, okay, this happened that year, and my grandfather will tell you that year we have a flood because of this and because of that reason. And they will be able to, better than a scientist, 100 times better, because they will see things that, of course, the scientist, which is like me, coming once per year, just few days and measuring and everything. The understanding of them is much is richer, of course, and more complete. And of course, they have another relationship with the glacier because it's part of their life and their environment. They are part of it. They don't talk about the glacier like something, an outsider, an object that which is outside there. It's like inside themselves. They talk like a part of. They are like you have the impression that they are moving with the landscape. This is the impression you have. Is with a lot of respect. They speak about the landscape because they understand the power of it. I don't want to use the word power, but I don't find another one. It's like they have a lot of respect. They understand that they are just a part of it and very small part of it. So when they talk in those terms. It's it's amazing how the needs they have. They're so different compared to the needs of a person living outside this area. Mm-hmm. They speak, it's like they don't need more than that. And they don't even have a full house in a region where you can find, in some places of Patagonia, it's raining 7,000 meters per year. It's so windy. You saw me in that picture, the wind like that, standing, like they live like that. Mm-hmm. And it seems that they don't need, they said once to me, well, it's true that it will be better if we have a radio to communicate with the community in the village, because sometimes there are some problems, and once we were flooded and we didn't know what to do, and the radio will help us to ask for some help. That's it. That's it. So the thing is that the point is that you can see clearly that they are totally. I mean that the state and all the political structure and is totally disconnected. Because there are not so many, no? So they are so easy to forget because it's like nobody's living there. No? They will not protest, they will not say anything, they will not raise any claim of anything. They're just living there, in the middle of their environment. And so whatever is done in terms of politics, they don't touch, they are not touched by them. Yeah, so I will show you last thing. So you see, this is a river, Baker River. It's really making demarcation of a frontier in between the road and between the valleys of that goes to the ice field. Okay, it's a big. This is the river. It has the stronger flow of the whole country. It's a very big one and so on. So you can see these horses there, and these men coming on the river like here with this small boat. And then we were waiting for him. We used to do our fieldwork with him. So he came to pick up us and the staff. It was a manner to proceed with him. So he's a local man. He lives in the valley with his family. This is his child. At that time, now he must be 20 years old. A very brave boy, really brave boy. He saved his life after. I will tell you a story maybe if we have time. But he saved his life to this man. So he's a typical local person, a gaucho. We call him gaucho. And he was born there and he has been living there all his life. So this is a typical way of doing our fieldworks, no? Riding the horses. And this time was very beautiful because these wild horses came to say, It was like saying hi to us. When we arrived, it just came running like that, they turned and then they left. Very beautiful.
You were going to show some pictures of animals and organisms in the water.
Yeah. So there are some pictures of animals on their surroundings, but because in fact, as I said, it's a very tough area, no? So they're not, you can see easily a very rich fauna. So we see some of them. So some birds and this is salmon.
Oh wow, so big.
Enormous. So this is a region. So this region is represented as through tourism, you know. So there are a lot of fishing activities and they do, you know, competitions and everything. This is salmon, and they used to come to those rivers at the end of their life. I don't know how you call it in English. You know, at the last
to spawn, no?
Yes, yeah. Exactly. So this was one of my PhD supervisors who fish it. So this is in the surroundings. This is the field work that we used to take sheep. Yes, we just had that. So the most importantly, this is what I wanted to show you. Look.
Oh.
I took this picture 10 years ago, casually. I didn't know what was this thing. I mean, this insect. And then I found a study showing that this is what I saw. Mm-hmm. This insect, the name is Plectora, something like that. The Dragon of Patagonia. He lives in the water, in the bottom of lakes, in rivers, and in the ice. Mm-hmm. Can you imagine? And they are all in environments where there is no pollution at all. Mm-hmm. Because they can't stand pollution. Mm-hmm. And they live in the ice. So, and there are other studies showing that, like this is a very recent study. They did it in New Zealand, mm-hmm. and they discovered new types of microorganisms living in ice.
Wow!
And this is a video.
Show me.
I will show you. Is it Darwin frog?
Oh. Oh, so beautiful.
Beautiful, no?
Yeah.
Yeah, that's it. Mm.
So what is it, with this experience you have with living in this, literally immeasurable landscape? Does it change your experience of other things when you encounter the rest of things in the city, or does it, yes, when you having lived there, does it change perspectives on everything else? And in what way?
So it changed everything. It was a very transformative moment because first of all, I start thinking about how much small we are. You know, we don't think about that. We just live life like this, you know, trying to have a good standard of life and these things and to study and to work, that's it. We don't think about that. And this was the first time I was confronted to something, you know, that something so big is just there. So it changed everything, of course. How can you, after how I couldn't live in the same manner, I couldn't think in the same manner. And also it made me think a lot about the work as a scientist. A big moment came after some years doing this work because I started thinking about the sense of what we do. It's the first time, it came to my mind this sense of the nonsense and the sense of things of being and doing. So I found everything so connected and disconnected at the same time. I was thinking how everything is connected in terms of environment, but political and economically, how everything is so disconnected. And I started feeling so bad because what I used to do was to collect money to do my research. So I went there every year, I installed my stations, and then I came back. I will show you pictures of the laboratory where I used to go. So then I came back with my data, and then I produced graphs and maps and everything. And I made my representation of this landscape. And I started feeling worse and worse. I started publishing papers and everything. Inside myself, I was feeling worse and worse because I was thinking, but so what? So I'm showing this retreat, I'm showing this, that, and so what? What about these people living there? What about this, everything which is happening there? How I'm part of it, what I can do, not to save something, just how can I be part of it? You know, that I'm real part of it. It's not like, it wasn't like the saver or something at all, you know? So of course it changed. And then this experience of field work and meeting people, and also I must say, I respect a lot of my colleagues and scientists and everything, but I disagree in the manner how we approach the areas of study and the people there, because I felt like when scientists requested a red carpet going there, you know, and they maybe without intention, but the manner to talk and to address, you know, problems and to communicate with people is like, oh, you will not understand. I'm the scientist, you know. And this really hurt me because it's so simple what we do. I mean, as a glaciologist, hydrologist, it's nothing like really big, no? So I went to the opposite direction. I started working with children and I started being more involved with the community. I tried to tell them it's not difficult. It's so easy to understand. And, you know, many things happened after. It became very interesting for me after, because I was involved with the other things and the community. And this led me to explore social sciences after. That's why I started trying to see other perspectives through science, to see the same thing. How can you then think differently about this, the same problems, in fact. So of course it changed a lot. It changed everything.
How do you feel the importance of being a scientist amongst all these things? You still do work on hydrology. You're still looking at water in a very scientific way in UNESCO, in your work. So, and otherwise too. So how do you see the role of this kind of knowledge in the experience you have of the world, like in the glacier? Where does it fit in? Do you deny that science, or it becomes part of another experience? Or how should we think of this scientific understanding in the way we experience and know something? Is knowing more than just the scientific way of knowing? And how can we bring that larger knowing into being, not from ourselves, but how do you communicate that being?
Well, what I think is that, first of all, as scientists, fieldwork for me is mandatory. I mean, the image you can have is not only an image. I mean, you need to experience. I mean, the word experience is something very important. It's not only observation, it's experience of it. Because science is interpretation also, it's a representation. And then you will make decisions based on those interpretations. So I think it's mandatory to go there, but not only from this standpoint of a scientist. I'm the scientist, I'm collecting data. So from the understanding that everything is interconnected, and that there is a whole landscape to understand, that you can't separate and understand a small thing to explain. You can't explain everything and anything by just looking like that, you know? So I think this is very important from a scientific perspective. Wherever you are, in UNESCO or in research center, wherever you are, I think the understanding that we live in an interconnected world and that we must consider all the elements, and our minds should be open. And it's difficult because we have not trained for that. Hundreds of years, no, in the separation of everything, no, separation of science. Of this is social science, this is natural science, and in natural science you have this, you have that, you have so hydrologists, glaciologists, climatologists, you know. So we must open, I think, ourselves in order to integrate and incorporate everything and try to go there with a different perspective, So the knowledge of people, for example, living there, you know, parents, grandparents, and everything, they have such a rich narrative about what we are trying to understand. But we never talk to them because we believe that this is not science. This is what we call citizen science. They are able to measure. That's why I had a project to work with children there. I wanted to show them how to manage a a meteorological station. We wanted to install a meteorological station in school near in that area for them to become glaciologists, no? Because they live there. And I think this should change, no? I mean, this divide in between society and science in the kind of hierarchy should be different. This is one thing. And most importantly, I mean, maybe it's the basis of everything that for me, we should think and question what we know and how we got that knowledge, how we came to know that thing, you know? Because at the moment we start thinking about that, then we will open out to other perspectives, I feel. But we don't do that. We just follow what the teacher said, and then what the Ph.D. director said, and then we repeat methods, and then we're happy because we were able to get a graph of something and representation of it.
Mm-hmm. But how do you think this will change? Because when we think of the world differently, then actually we need to change this perspective, you know, of the way we know the world. The way we know the world is in these silos of knowing.
Mm-hmm.
So an anthropologist knows the same thing in a certain way, a scientist knows it in a certain way. But what is holistic knowing? And does holistic knowing relocate us as human beings in the world? Do we see the world differently when we know it differently or more holistically?
Yeah. So what I think is that we will not have a choice but to change it, because the Anthropocene is there, no? So then I don't think we can escape of that. So I really think that we can hear talking about holistic approaches and multidisciplinarity, these speeches more and more often. It's even becoming fashion, I feel, really. So I think this is very positive. However, in my opinion, the problem that we will have to cope is from an epistemological perspective, because we don't know how to do, you know, and this is a big problem. How can you integrate in your mind when you have been trained to separate your whole life and generations and generations and generations? I think it's very difficult. I think it's difficult. So for me, the starting point is to accept that we are part of the whole, that we're just a part of the whole, that nature is not we and nature, that we are nature too. And that nature is not a service. It's not just a matter of resources, of course. It's not a matter of a beauty, because it's always beauty or resource. How can we use this, or how can you experienced that maybe when you were working with fishing communities, no? That it's another reality. So of course, I think there must be a big shift, and this can come from almost a different philosophical idea of us, of nature, of what I've been doing, and to think critically. No?
Do you think this is slowly changing in the institutional world, in the research world? You think it's shifting slowly?
I think so. I have the impression that it's going there at least. I have seen hydrologists talking about incorporating the social sciences in the work that they do, which is really something important, because some years ago, was impossible to think. And in other disciplines, of course, I think it's changing. But I think we need to think more and to be able to question more things and to go into deeper thoughts and deeper reflection. I don't think we are in the pace that we must be. The processes are already there. They go very quickly.
Do you think that the slow change you're seeing is because we are seeing the limits of the separation, because of how we are not able to solve real world problems? Even water problems are not solved. No, we are predicting water crisis everywhere. So with climate crisis, water crisis, whatever you might call, so many different ways of knowing the planet is shifting. So it's also that which is the idea of this crisis, which is driving people to saying, but to answer the question, to know what's happening, we have to think differently.
This is a problem because I think we are thinking and we are talking more because we are in a crisis. And this is not a good sign, because means that still we are seeing nature as a resource. You see, it's because we are scared and we are afraid of not having what we need that we are reacting and talking. And this is our limits are that. This is the criteria to fix our limits is through the resource. And this is a problem. You see, at the moment we start talking differently, we will not react to a crisis. It's because there is an understanding that we are the system, we are the whole system. I'm not talking only about nature and human beings. I'm talking about politically, economically, socially speaking. We're all in the same system. We're just, moving the whole day. Whatever I do every day since the morning until the evening, it's political. I really believe it. And what I do, it will impact in many ways, many other things. What I say in my office, what I think, what I respond, or whatever. So the thing is that, we are reacting, and we are reacting to a crisis, and it's a problem. I think it's a problem. We must react, that's for sure. But the reason why we react, this we should think about. Mm-hmm. Because that reason will frame and will build the path of the future. What we will do in the future? We will continue reacting to crisis, or we will start thinking differently.
Mm-hmm. So the shift has to be more internalized, but it has to become part of us, this thinking. It's not just about that. I mean, this could be a process, but we have to make it very much the way we think we are, rather than just, it's a way of being, being, and how to become that being is a long process of unshackling the years of thinking in the separations.
I mean, it made me really think about Gandhi and Hind Swaraj, who talks about self-governance. And it's exactly what I think we should do now, is to go inside and to think about, in what do you believe? What are your values? What do you know? How did you get all of these things? Where do they come from? And what are you doing with that today? What are we doing? In that manner, we build our communities, and then we interact, and then we flow with this environment in which we think we are, in an upper position of, And of course, I think it requests to an internal, deep reflection, I feel, really.
Well, it's been a wonderful conversation.
Thank you, Ravi.
No, thank you. It's so rich to see it from the ground of what knowing nature means. How do we know nature? And this report, to see what are the origins of those reports. There's all this prediction. This is how it really is. And also to know better, scientists struggle with one's own knowing and experience,
yes.
Which you personify. So a mind trained in that, as a human being, you're trying to reconcile the way you have been in nature, are in nature, in a glacier, and the way you then have to represent or portray it in science, and the big gap between the two. I think this is where the artist can try and bring things together.
Yes, exactly.
We don't have this separate way of knowing. We can identify different knowings, but we have to somehow think of this as one space.
So this is exactly one aspect that I feel is changing, because, I have been working as a scientist since, I don't remember now, 15 years, I don't know. And I'm involved in science since, I don't know, maybe 30 years. But since a few years ago, I started hearing about, in the scientific environment, how much art is important. And they are bringing artists now. So this is a big change. This is a big shift, because art wasn't recognized like something, important to understand ourselves and nature. And there are more and more now involvements and trying to converge science and art. In UNESCO, there are many initiatives.
UNESCO Paris doesn't have place for Indian artists to come and work with them. Yes.
There was a beautiful exposition of a photographer. They exposed it in the whole site. Beautiful, of landscapes and people living in those landscapes. Of course they are.
Okay.
Of course.
Thank you so much for this
You are
conversation.
welcome. Thank you to you, Ravi.